Welcome back, everybody. This video we're going to be simplifying radicals. First thing we're going to do is rationalize 8 over radical 3. Process called rationalizing the denominator. Basically, we're going to multiply it by the number 1. But we're going to rewrite 1 as square root of 3 over square root of 3. And you always do this when the radical's in the denominator. You want to get rid of radicals in the denominator. So what happens here is the numerator, we have 8 square root of 3, then just over 3. This right here really means square root of 9, right? Square root of 9 is 3. So our final simplified answer, rationalizing the denominator, 8 square root of 3 over 3. Let's try it again. Square root of 88. Square root of 88. 88 is not a perfect square. However, we can break it down into 4 times 22. 4 is a perfect square. 22 is not. The square root of 4 is 2. But then we're just going to leave square root of 22 as is. Next up, we're going to simplify 192. 192 can be broken down into 64 times 3. We can take the square root of 64 and get 8, but we can't take the square root of 3. We leave it inside the radical. Alright, next up, we're going to do some multiplying. Now, there's several ways to do this. We could multiply the 4, the 10 together, and then 3 times 12 times 6 times 2, but we're going to break it down individually. Let's rewrite 4 square root of 3. Let's rewrite 10 square root of 12, but I'm going to rewrite that as 4 times 3. Now, we could do, actually 4 times 3 may not be the best choice. Given that we have a 6 and a 2, watch what's going to happen. Yes, 6 and 2, we're going to do 6 and 2. And even though 6 is not a perfect square and 2 is not a perfect square, watch what happens here. Alright, 4 square root of 3 times 10 times square root of 6 times square root of 2. And here's the other square root of 6. And oh, this was a square root of 2. I copied it down wrong. Yeah, this right here should have been a square root of 2. Alright, now these two come together to make square root of 36, which is just 6. These two come together to make square root of 4, which is just 2. So we're multiplying there. We still have the 10. We still have the square root of 3. Nothing happened there. Alright, and then now we have 4 times 10, 40, times 6 is 240. Times 2 is 480. 480, and we just have a radical 3. There we go. So the key here is, even though, yeah, we could have broken 12 down into 4 times 3 and then reduced that to square root of 4, square root of 3, we still have, we had the 6 and the 2, and I saw an opportunity to combine those, multiply them together, and thereby eliminating those radicals. Several ways to do it. That is probably the quickest way. Let's look at another one. Square root of 5, square root of 12, and square root of 50. Let's first break each one down the best we can. Four times 3 and 25 times 2. The square root of 4 is 2. Square root of 3 we leave there. Square root of 25 is 5, and then we have the square root of 2. Alright, and then here we have 2 times 5 makes 10. The 2 times the 3 makes 6, and the 6 times the 5 makes 30. And there's no way to break down 30 any further. This simplifies to 10 square root of 30. Alright, 4 square root of 32 times 2. Well, Let's go ahead and multiply these together. 32 times 2 is 64, and that turns out to be a perfect square. So really this is 4 times 8, and we just get 32. Look at the next one here. Okay, now we're going to change it to multiply or adding and subtracting. You can add and subtract radicals so long as they're the same radical. So you can sort of think of this as 5x plus x minus 2x. And wouldn't that be 4x? So same thing here. 5 square root of 7 plus 1 square root of 7 is 6 square root of 7. Minus 2 square root of 7 equals 4 square root of 7. And that's the final simplified answer. Next one, another subtraction problem. Let's simplify the radicals first. We have 2 square root of 28. I'm going to break down 28 to 4 times 7. 5 minus 5 square root of 63. I'm going to break down 63 to 9 times 7. The square root of 4 is 2. So now I have 2 times 2, square root of 7. The square root of 9 is 3. So now I have not 5 times 3, square root of 7. 2 times 2 is 4. 4 square root of 7. 5 times 3 is 15, so it's 15 square root of 7. 4 minus 15 is a negative 11, and it's still next to the square root of 7. Alright, last one. 7 square root of 27 plus 5 square root of 48. Alright, 27 can break down. 9 times 3. 48 can break down into 16 times 3. We can take the square root of 9 and get a 3. We can take the square root of 16 and get a 4. 7 times 3 is 21. 5 times 4 is 20. 21 plus 20 is 41. 41 square root of 3 is the simplified answer. Hope this helped. Thank you for watching.